Okay, let's unpack this. It's barely mid-2025, and wow, the speed AI is evolving, especially how machines get both images and language. It feels incredibly fast.
It really does. Thinking back to even early 2024, it's like a different world.
Totally jarring, right? And this convergence, AI seeing and understanding what we say, it's driving some really revolutionary stuff.
Absolutely. And the ambition we're seeing now, that it's really being realized. The way AI processes visual and linguistic info has just exploded. Groundbreaking advancements,
Yeah,
truly.
this unified understanding.
It could lead to AI that gets really complex situations, seamlessly pulling in information from multiple senses. Think about accessibility or even creative content generation could be transformative.
Exactly. And that's precisely what we're digging into today. We've got this fantastic article just out, giving a great overview of the latest in vision language models, VLMs. Yeah, over the past year. So consider this your shortcut to getting totally up to speed. Our mission, for you listening, is to pull out all the key trends, the hot new models, these mind-blowing new capabilities, without you having to sift through tons of research papers
We're finding those goldie nuggets for you.
and telling you why they actually matter.
Yeah.
Because this past year, it's been pivotal, a real speed up in VLM development. We're way beyond just basic image captions now.
Oh, definitely. We're talking sophisticated reasoning, agentic behavior, even understanding video
This is the
nuances.
scope.
It's huge.
It really is. We're looking at totally new model architectures, like these any-to-any models aiming for like universal understanding.
Yeah.
Then there are models built specifically for complex reasoning.
And those tiny models that are surprisingly capable.
Exactly. And new techniques like mixture of experts, decoders boosting performance, the rise of vision language action models bringing AI into robotics,
Wow.
and specialized skills, letting VLMs find objects, check for safety, totally change how we interact with documents, create AI agents that see their environment, even tackle video. And we'll get into new ways to fine-tune them and better ways to measure how good they are, right? New benchmarks.
That's the plan. All the key pieces.
All right, let's jump in. One of the most exciting bits seems to be these any-to-any models. The core idea sounds ambitious.
It is creating models that can just handle any input, image, text, audio, and output in any of those forms.
Like a universal translator,
Yeah.
but across senses, not just languages.
That's a great analogy. Instead of one AI for images, another for text, these learn to connect everything in a shared internal space. So the idea of dog in text links directly to a picture of a dog, maybe even the sound of a bark.
Makes sense, connects the dots.
Exactly. And we saw early steps like Meta's Chameleon. It handled text and images in and out, though it couldn't make images.
Right.
Then Lumina MGPT built on that, added image generation.
But the real standout now seems to be Quinn 2.5 Omni. That thinker-talker architecture sounds like a big step.
It does. One part generates text, another instantly turns that into natural-sounding speech, streaming it.
Wow, near real-time bridging of modalities.
And building on that trend, there are other strong examples too.
Like,
Well, Mini CPMO 2.6. It's an 8 billion parameter model handling vision, speech, language understanding, and generating.
8 billion.
Yeah.
Still pretty big, but covering a lot.
And DeepSeek AI's Janus Pro 7B. It uses this smart design, decoupling visual understanding from generation, so it gets good at both.
Okay, decoupling. Interesting approach. It feels like the core idea here is just exposing models to more types of input helps them build a richer, deeper understanding overall.
Rad. That's the intuition, yeah. It seems to hold water.
Now, another big leap seems to be in reasoning.
Right.
We know LLMs got good at solving complex problems logically.
Right.
And now VLMs are starting to show similar skills, but with images and text combined.
That's right. And until recently, open source options for multimodal reasoning were, well, pretty scarce. Quinn had that experimental QVQ72B preview, but it felt more like research.
But now there's Kimi VLA3B thinking from Moonshot AI. This sounds like a key player.
It does. It uses a special image encoder, MoonVT, and that mixture of experts decoder we mentioned, which we'll unpack more later. It's big, 16 billion parameters total, but only about 2.8 billion are active for any input.
MOE again. And it's fine-tuned differently.
Yeah, using long chain of thought examples and reinforcement learning, that helps it tackle those really complex multi-step reasoning tasks involving both visuals and text.
And there's an instruction-tuned version too. Kimi VLA3B Instruct.
Correct. Makes it more practical for applications.
And it handles more than just static images, videos, PDFs, agent stuff.
Yep. Suggests AI moving beyond just seeing and interpreting to actually reasoning through complex visual scenarios. It's a significant step.
Okay, so from complex reasoning, let's flip to the other end. These smallly capable models, the old thinking was just bigger is better,
Yeah.
right?
That was the default for a while.
But now there's this push for smaller, more efficient VLMs. Why the shift?
Several really good reasons. Smaller models need way less compute power. That makes them cheaper to run, easier to deploy everywhere.
And crucially,
Crucially, you can run them locally, on your own device. Big win for privacy and for speed, low latency.
and small here means, what, under 2 billion parameters?
Yeah.
Something that could run on a decent GPU.
Generally, yeah, that's the ballpark the article mentions. And the small VLM family is a prime example. They really targeted tiny sizes down to like 256 million parameters.
Quarter billion parameters.
Wow. And small VLM2 focused on video understanding within that small footprint. Found a sweet spot around 500 million parameters.
And there's even an app, Hugging Snap.
Yeah, shows it's practical. Sophisticated video analysis running right on your phone. Pretty cool.
That is remarkable. Then there's Google DeepMind's Gemma 3 4B. What's special there?
Small size, only 4 billion parameters, but a huge context window, 128,000 tokens.
128K context in a 4B model? That's massive.
It is. Plus support for over 140 languages. It comes from that powerful Gemma 3 family. That long context lets it handle much more info, visual, and text.
Makes sense. And Quinn has a small one too.
Right. Qwen 2.5 VL3B instruct. Versatile, good at localization, document understanding, even some agent tasks. And still has a decent 32K context window.
And for the tech folks listening, you can actually run these smaller ones using things like MLX, llama.cpp.
Yep, the article even gives a command line example for small VLM, lowers the barrier to trying them out.
Good point. And yeah, models like Moondream 2, Florence 2 were early steps, but the focus now is definitely on these newer ones. Okay, let's circle back to mixture of experts, MoE. You mentioned it with Kimi VL. Sounds like a smart way to boost performance without just making the whole model gigantic.
It's a really clever architecture. Think of it like having a team of specialist submodels, the experts.
Okay.
For any input, a router directs the data to only the most relevant experts. So if it's a cat picture, the cat expert activates, the car expert stays off, saves compute.
So like calling in only the specialists you need, that sounds way more efficient computationally.
Exactly. Faster inference usually, because only a fraction of the total parameters are doing work, can also help training converge faster.
What's the catch?
Main trade-off is memory. You still need to load the whole model, all the experts, into memory so the footprint can be larger.
Gotcha. And structurally, they slot these MoE layers into the transformer blocks, replacing the standard feed-forward networks.
Typically, yes, like a modular upgrade. And the article points out VLMs using MoE decoders are showing really good performance gains.
We saw Kimi VL. Any others?
Yep. MoE Alava focuses on efficiency, reducing hallucinations. DeepSeek VL2, known for broad multimodal skills. Even the latest Llama 4, has vision now and uses MoE.
So it's clearly a hot research area.
Definitely promising for VLMs.
Okay, so we've covered models handling any data, models for reasoning, small models, and these expert-based models now. Vision language action models, VLAs. This is where AI starts interacting with the real world, right?
Pretty much. VLAs are basically VLMs adapted for robotics. They take visual input, text instructions, and output robot actions.
How do they represent actions?
Key thing is adding special action and state tokens. These let the model understand the physical environment, what the robot can do, its current state, even time.
So the tokens give it eyes, hands, and a sense of planning.
Yeah.
Almost like giving the VLM a body.
That's a good way to put it. These tokens get added to the input, and the model outputs the action sequence. Think zero and zero fast from physical intelligence.
Right, trained on multiple robots.
Yeah, doing real-world stuff like folding laundry, assembling things, showed strong performance, even zero shot.
Impressive. And NVIDIA's GR00TN1 for humanoids.
Exactly. Foundation model for humanoid robots understands images, language, generates actions, and both use the Lee robot dataset format, which helps standardize training data.
That standardization is important. The article also mentions VLAs might include things like UI navigation.
Yeah, there's some debate if that counts, but it touches on the broader idea of VLMs interacting in digital environments too, not just physical. Agentic workflows.
It really feels like AI moving from observing to doing in the real world and digital spaces. Okay, shifting slightly. Specialized tasks. How are VLMs handling classic computer vision stuff like object detection, segmentation, counting?
They're generalizing really well here. Taking an image and a prompt, even open-ended text, and outputting structured info like localization tokens, pinpointing objects.
VLM was an early one, taking segment striped cat and giving back coordinates.
Yeah, and even segmentation mask info via codebook indices. Clever unification.
And newer ones.
PalaGemma 2 improved on it. Malmo from Allen AI can do pointing with dots, object counting, and Qwen 2.5 VL is also strong here, even finding UI elements.
Blurring the lines between AI fields. Now, a crucial one, multimodal safety. As VLMs get powerful, we need guardrails, right?
Absolutely critical. Just like we need safety filters for LLMs dealing with text, we need them for VLMs seeing images. They filter inputs and outputs to block harmful stuff, violence, explicit content, especially in production.
And Google Shield Gemma 2 was the first open one.
Yep. Takes an image, content policies, and flags violations. Useful for filtering image generation outputs, for example.
And Meta has one too, LlamaGuard 4.
Right. Densely pruned, multimodal, multilingual. Can check text only or multimodal stuff, filter VLM outputs, even whole conversations.
Good to see safety keeping pace, somewhat. Okay, let's talk Retrieval Augmented Generation RG. We know it for text. How's it working multimodally?
Well, the old way for complex documents, like PDFs, was kind of clunky. Parse to text, retrieve relevant text snippets, feed to LLM. That parsing step, prone to errors.
Yeah, sounds brittle. How do VLMs help?
They let us work directly with the visual document content, bypass that messy text parsing. Multimodal retrievers take PDFs and a query and return relevant page numbers and confidence scores.
Much cleaner.
Yeah.
The VLM essentially sees the document layout and content related to the query.
Exactly. Two main ways they do this. First, document screenshot embedding DSE or MCDSE. Separate text and image encoders create a single vector per query passage. Similarity gives relevance.
Okay, single vector approach.
In a second. Colbert-like models.
Okay.
ColPoly, ColQuin2, ColSmall VLM. Also dual encoders, but they output multiple embeddings per token or image patch. Similarity uses Maxim, finding the best match between any query token and any image patch embedding.
More granular.
Right. Often better performance, captures nuance, but usually more computationally expensive. Though ColPoly is noted as easier to maintain, maybe because it's a single model.
Good to know. And people can find these on Hugging Face Up under Visual Document Retrieval.
Yep. And they're often trained on benchmarks like VDOR, real-world financial scientific documents in English and French.
Okay, moving toward the cutting edge. Multimodal agents. This feels like where it all comes together. VLMs enabling intelligent interactive systems.
Totally. We're seeing sophisticated agentic workflows now. Not just document interaction, but operating computers via GUIs, graphical user interfaces.
AI seeing and clicking, that's a huge step for automation and assistance.
It is. UiTARS 1.5 from ByteDance, as mentioned, controls browsers, OS, phones, even games. And Majime 8B is built for UI navigation and physical robotics. Plus, general models like Qwen 2.5 VL, Kimi VL are showing strong GUI agent skills, too.
And there's a library for building these fall agents.
Yeah, lightweight, supports VLMs, uses the React framework for reasoning and action.
How does it use the VLM?
Two main ways. Giving initial images for context, like in document tasks, or dynamically getting images, like taking screenshots for GUI control. The agent needs to see the current screen state.
Makes sense. The article gives examples, even a command line one for a web agent using browser control and a VLM.
Right, really shows the potential for automating complex web tasks. And given the reasoning needed, the article suggests using capable open source models, like Qwen 2.5 VL again.
Good tip. Okay, can't ignore video.
Yeah.
Video language models. Many VLMs handle video as frames, but true understanding is harder, right? Temporal stuff, lots of data.
Exactly. It's not just a stack of photos. You need to grasp how things change over time. Frame selection is key.
So how are models tackling this? Meta's long VU.
Yeah, it uses DynoV2 to downsample frames, remove similar ones, reduces redundancy. Then it picks frames most relevant to the text query by projecting both into a shared space.
Clever two-stage filtering. What about Qwen?
Qwen 2.5 VL handles long context and dynamic frame rates. It was trained on varied frame rate videos and uses extended multimodal ROPE to understand absolute time and event speed.
ROPE for time understanding. Interesting. And Gemma 3.
Takes frames interleaved with timestamps right in the text prompt. Another way to give temporal context. Lots of different strategies being tried.
Fascinating. Okay, finally, how are we getting better at training and evaluating these things? New alignment techniques, better benchmarks.
Crucial pieces. Preference optimization is gaining traction. Instead of fixed labels, it learns by comparing responses.
So the model learns what humans prefer.
That's the idea. The Troll library supports direct preference optimization, DPO, for VLMs now. You give it an image, question, a chosen answer, and a rejected answer.
And it learns to pick the better one.
Exactly. Datasets like RLAFV provide this kind of preference data over 83,000 samples. The example in the article with the baseball catcher makes it clear.
And Troll has tools like DPO config, DPO trainer to make it easier.
Yep, helps set up and run the fine-tuning.
And on the evaluation side, benchmarks need to keep up, right?
Definitely. As models improve, old benchmarks get too easy. We need new ones, testing harder, more specific skills. MMT bench sounds like a big one.
Massive, yeah. Over 31,000 questions, covering image, text, video, point clouds, requires expert knowledge, localization, reasoning, planning.
Sounds incredibly thorough. 32 metatasks, 162 subtasks, really comprehensive.
And MMMU Pro, an even harder version of MMMU.
Right. Ups the difficulty. Vision-only input sometimes, more answer choices, more realistic variations like different backgrounds, fonts, a tougher test of true understanding.
Vital to have these evolving benchmarks. So wrapping up the models, the article gave some quick picks.
Yeah, useful summary. Quen 2.5 VLO for versatility, agent skills, math. Rolmo CR for OCR. Kimi VL thinking for reasoning. Small VLM2 for tiny video tasks. Llama 4 Scout and Maverick for long context, and Molmo as an open model good at localization.
Nice little cheat sheet.
It really is. The pace over this past year, it's just been incredible for VLMs. From basic recognition to complex reasoning, agents, specialized skills.
And seeing those smaller, efficient models emerge, too.
A huge amount of progress.
Absolutely. And hopefully, for you listening, this deep dive gave you a clear picture of these key advances, saving you some time wading through it all.
Yeah, we tried to pull out the important bits. So as you think about all this, maybe consider how these VLM leaps might impact your own field, your hobbies, even just daily life soon.
What new things become possible when AI really starts to understand the visual world?
Exactly. Maybe check out some links in the original article if specific areas caught your interest. There's a lot more to it.